I had a problem on the Wiltron 6409 Scalar Network Analyser in that a couple of the connectors on the sensors were badly corroded and I needed to change them. So I got some replacement connectors and I've had to machine away some of the PTFE on the back of both of these connectors, and the result of that is that it's likely that the pin has shifted inside. So I needed to gauge the pin depth, how far the pin sticks out of the connector, because if it sticks out too much in there, it'll jam into the pin on the other connector and ruin the connector. So I needed a simple gauge system. So what I made is this little bushing here, or donut shaped thing, that is a precise thickness. It is exactly 0.2123 inches thick. So with that, I can then use that and a depth micrometer to figure out exactly how far the pin is sticking out, because on these connectors the reference plane is actually way down inside. It's not the surface there. So to see how this works, there's a couple of measurements I need to make. So first of all, I need to measure the distance, the depth of the pin from the top surface, which I'll call distance B. So we'll just measure that like so. We'll just turn the micrometer, just let's start with 3 clicks, lock it in place, and read that off. And I've done this before, so I'll tell you now that it's 0.1543 inches. Right, the gauge I then drop into there, so that gives me a depth that to the gauge from the reference surface, and I drop the depth micrometer in there again and measure that. 3 clicks, lock it in place so when I take it off it doesn't spin, and that distance is 0.1458 inches. Now I know that the thickness of the bushing, the gauge bushing that I've made here, is 0.2123, so I can use a simple equation to figure out how high the pin is from the reference surface, which is the distance of the gauge A, the distance to the pin B, and the thickness of this here. I just go A plus C minus B, and that gives me an answer of 0.2038 inches from the reference surface to the top of the pin. Now the tolerance for that starts off at, it goes between a range of 0.187 inches and 0.207, and the measurement I got was 0.2038, which is inside of the tolerance. So that height of that pin is in tolerance. But because this is an instrument, what I really want to do is make sure that the pin is at its maximum end of the tolerance. So it's allowed to stick out to 0.07. So I can push this pin out from the back another 0.03 of an inch, and it will be on the edge of the maximum tolerance. So how do we adjust the pin extension? We start with this lathe, put the connector in the jaws there so that they're seated up against the face of the jaws, and then simply move the slide in until it's just touching, and we want to advance this by 3 thou, so we'll just touch that. Okay, so it's just touching now, and advance that by 3 thou, and we end up with a precision press. Now there's going to be some spring back from this, so I'll put it in 3 thou, back that off, take the connector out of the jaws, and then we'll check the depth with the depth micrometer, the extension. Three clicks, tighten it up so it doesn't spin, and the reading we've got is 4 thou. So what is that? The target we want is 2. We had 5, and now we've got 4, so I've got 2 thou to go. Right. So we'll put the connector back in the jaws, move the slide up until it's just touching, right, and we'll advance it 3 thou again. 1, 2, 3, because I don't want to overshoot. So we'll push that up, back it off, take the connector out, check the depth again. So we want, our target is 2. So we'll turn that in, 1, 2, and we've now got 3.5. So I'm 1.5 thousandths off target. So we'll go through the exercise again, just sneak up on the value, just right, advance it, 1, 2, 3. Okay, back out again, getting there slowly. Measure the depth of the pin. And still 4 thou, just under 4 thou. So I'll just do it another go. We'll just advance it a bit more this time. So, tuck that in, press that in, hold it there. We'll go 4. 1, 2, 3, 4. Right, back it off. There we go again. Check the depth. Right. Okay. We're just over 2, 2.5. So I'm going to leave it at that. I'm not going to go any further. I'm just going to say that that is good enough. That's 1.5 thou off the upper tolerance. And that is close enough. Right, so my method of adjusting the pin depth on these N-type connectors is just one way of doing it. I'm not saying it's the best way, but I needed a quick and dirty way of accurately setting the depth of the pins on these female connectors, and the method that I've came up with required only the machining of one bushing, which didn't have to be a precise thickness. I had to know what the thickness was, but I didn't have to machine it to a specific thickness. And with that one machine part and the use of the depth micrometers here, I'm able to accurately measure and set the pin depth on the connectors that I have. Mission accomplished. Right, so my method of adjusting the pin depth on these N-type connectors is just one way of doing it. I'm not saying it's the best way, but I needed a quick and dirty way of accurately setting the depth of the pins on these female connectors, and the method that I've came up with required only the machining of one bushing, which didn't have to be a precise thickness. I had to know what the thickness was, but I didn't have to machine it to a specific thickness. And with that one machine part and the use of the depth micrometers here, I'm able to accurately measure and set the pin depth on the connectors that I have. Mission accomplished.